Okay, now that we have these conversions down, we can handle 3, 4, and 7 and 8 a little bit better. Okay, now we could actually get by with number 3 without even converting it. So what I mean by that is 5/3 is, if I think about 5 divided by 3, it's 1 2/3, right? So we have 1 2/3 pi. All right, and then remember, pi is just the straight angle. It's 180 degrees, right? It's one of our common angles. So now, do you really even need to convert it? Can we do 1 pi, then followed by a 2/3 pi? So here's what 1 pi would look like, right? Straight angle, and then can I estimate another 2/3 of what I just did? So 2/3 of that is probably gonna be somewhere right around here. And that might be enough. But if you have a hard time with that math, that's okay. We've got a backup plan now. I just showed you, or we just practiced how to convert this to degrees. So the other or here is to do 5 pi over 3 times 180 degrees over pi. Cancel. Okay, now multiply 5 times 180, divide it by 3, it gives me 300 degrees. Okay, so now I converted it from radians to degrees, and this problem is just like 1 and 2. Okay, so positive angles rotate through first quadrant first, negative the other direction. So 300 degrees, we can kind of check it this way, right? 90, 180, 270, and then I have 30 more degrees to go. So we just kind of estimate that. So it looks like I had it in the right spot. Which quadrant does this terminate in? Quadrant 4. Okay, let me show you one more and then let you try 7 and 8. Negative pi over 4. Once again, that's a common angle you might start getting memorized. Or just think about it this way. A right angle is pi over 2. Half of that is pi over 4. Can you draw half of a right angle? I think you probably can. Okay, so you could just figure this out by remote memorization. Negative means, remember, we're always starting in standard position. So negative is rotating this way, and half of a quadrant is going to be right there, right? It's about negative 45 degrees. Okay. However, if you're not comfortable with that yet, we can always do this. 180 over pi, cancel, cancel, do the math, 180 divided by 4, and we get negative 45 degrees. Okay. Lies in quadrant 4 again. All right, so 7 and 8. See if you want to. I think this one's pretty easy. Do 9 divided by 4, and you can change it to a mixed number. This one might be a little tougher. I don't know. Your pick. Maybe just try both. If you struggle, though, just convert them to degrees and draw those angles. Okay, pause and give yourself a couple minutes to do that. Here's your feedback on 7. If we convert it to degrees, we get 4 and 50, or 15 divided by 6 is 2 and 3/6, or 2 1/2. Your call. This is probably going to save you some time if you can just do this, because think about what 2 pi is. 2 pi is 1 revolution. It's 360 degrees. So if I know that, positive rotates this way around, so I already did 2 pi. Now I just have a half pi left over, which is just a right angle, right? Pi over 2 is a right angle up here. So that gets you there, but also we'll 450, right? So 450 is the 360. If you do the math, subtract 360, we've got 90 left over to get you right here. So show this little snail in the middle to show the direction. And then our terminal angle ends here. I guess just kind of darken it a little bit because it's hard to see. Make it obvious where it's at. Now, you can't really name the quadrant here. If anything, we would say between quadrant 1 and 2, but technically it doesn't lie in a quadrant. Okay. All right, and number 8, negative 2 1/4 or negative 405. So now it's negative. So starting here, we rotate clockwise now, negative 360, and then I've got another 45 more degrees. So just split this quadrant in half, and it lies here in the 4th quadrant. Okay, and those are actually coterminal angles. When they land at the same spot, we call them coterminal, which is something we'll save for tomorrow because it's taken a while already. So